Tonight, peeps, is I'm gonna hand out this document which has some info about your terminology. So I handed out the terminology last week, the listing, and these are the definitions. Like I said, the terminology test will come up usually the last week before finals, which y'all know that we do finals the week before. Let's see this. The week before finals week.
Make some flashcards.
I'm doing it right now.
Yes, if you've got that, all you need to send it without me having to set up.
So you're gonna make those parts all with.
Yeah.
You should drop a link to it
Oh, in the Discord.
in the Discord. Hell yeah. I like these.
Alright, so what this is your terminology list. You'll see at the top, units, the definition that I want y'all, that we will use in here, decimals of a foot and surveyor's units. Scales, there's 3 types of scales: graphic, verbal, and ratio. Title block. So these are just definitions of stuff that you would, did you get one of these? No, you wouldn't. Definitions for the terminology sheet. Like I said, that test is the next to the last weekend normally in the semester. I wanted to hand that out earlier in case y'all wanted to take notes on it and write those down. I'll be giving y'all some notes on your first project here in a little while. Alright, so this one right here, this scaling exercise, depending on how much lecture and discussion we have tonight, probably gonna get y'all to fill these out and turn these in before you leave. Now, we're gonna be doing this with or as a group if you want to. If you do not have your engineer scale with you tonight, just to be a heads up that they can drop it anytime, because these are just, they should be just easy grades, but they're kind of filler grades that don't take a lot of time. I can give it to y'all and everything will be good. You should have 2 over there, Brandon.
There's my 100.
Brandon, done.
Mr. Pete.
Yo.
I grabbed this real quick.
Yeah, there's pens and pencils up here. It's like I said, in a little while, I'm gonna give y'all some time after lecture to work on these. But for those of you that don't have one, you can work with somebody, scoot over by, but let's get these handouts, these fill-ins turned in tonight. So after we get through with everything, then y'all can huddle up and sit down. But we got some lecture to do in a little while that's gonna take up a good part of the class tonight. So don't try to do this while I'm lecturing, because there's some pretty important stuff. It's gonna be the scope of your project, your first project. So what you've got there, when you look at your scale, like I said, if you don't have yours, maybe scoot over with somebody else if they don't mind. Let's go to the easy one first, the one with the bigger spaces. Look for the one that says the number 10 on the end. I'll go ahead and hit this other light for this. I should be able to see that okay. So when you see this number 10, your civil scale, so up until now you've been using architectural scales. 3/8 of an inch equals a foot, 1 inch equals a foot, 1 foot equals a foot. Every scale that you've been using except for your diagram type classes like electrical and instrumentation where it was NTS, not to scale. Your scales all ended with equals 1 foot dash 0 inches. In the engineering world, different type of scaling, all of your scales begin with 1 inch equals a foot. Whenever you put it in your title block, if your scale is 1 inch equals 10 feet, in your title block for scale, you can just put, we don't put this dash 0 inches on that. That top one up there that we're gonna reference in a minute, 1 inch equals 30 feet. So on this scale, where it says the 10 on the end, and if somebody close needs one, y'all can look at mine. So this one, number 1 right here that you see, If you were to get a regular ruler out, you would see that the distance from 0 to the number 1 is 1 inch. Up here on the 30, the distance from the 0 to that line right there is 1 inch. So that tells us in a drawing that is scaled 1 inch equals 10 feet. If I put this or a regular ruler up there, I can say, all right, that's 1 inch long, that's 10 feet. Build that sidewalk 10 foot long, and then we turn. That's the purpose of the scales, is to be able to get out and reference that drawing. We use them quite frequently where we're at because something I told y'all last week in here, in the civil world, we don't show a lot of dimensions, if any, on our drawings. Actual dimensions with extension lines, dimension line, arrowheads, and the text above it. That's not how we notate drawings in the civil world. So we're not gonna be able to look up there and just find that measurement. So we're gonna go to it with the scale. So if it's 1 inch equals 10 feet, something to think about, all of these numbers that you see across here, no matter what scale, what blade you're looking at on that civil scale, that engineer scale, all of those numbers should have a 0 behind it. That's the first thing I need y'all to remember, because you're gonna be working on an assignment today and somebody's gonna turn something in with 563 feet. A line at that scale wouldn't fit on a page turned sideways 563 feet long. So that's why tonight I'm okay with, after we get through with y'all working in groups, maybe looking and talking with each other, maybe one person does it and then the other person checks it or something, however you wanna do it. I'm not gonna get you for cheating on this one, although I do wanna see that everybody's doing it, but I know that y'all probably don't have all your scales. So each one of these, when you look at these numbers, understand that each one of those should have a 0 behind it. That is not 1 foot from there to there, as the note says. That is 10 feet. That is not 2 feet from there to there. It's 20 feet. So you just envision, no matter what blade you're looking at, Mr. P, these numbers are pretty high. I don't care, put a 0 behind it. So that's the first thing I need you to learn about that scale. The next thing is that each one of these little lines and medium-sized lines and longer lines, each one of those lines represents a distance of 1 foot, no matter which scale you're looking at. So if you're looking at some of these scales, you can see those little dashes are real tight together. That's okay, they still I think they still reference 1 foot each. See, nope, right here, made a liar out of it. So if I were to come up here on the 30 scale, same thing. I could measure from 0 to what would be 30 feet. They don't have the 3 on there. I don't know if a long time ago somebody said, look, we can take all these zeros off. They'll understand it. We don't have to put all these numbers on. They'll understand it. And we just cut the cost by 15% to make one of these. I'm not sure why it was, when it was, I don't even know that. I just know that for my drafting career, sometime well before I came into the business, somebody decided to take all those zeros off the scale. That's okay. The way you measure with your engineer scale, you put one end of the line on 0, and you see where the other end falls. So if I were to randomly put a line on there and measure it, put one end of that line on 0, and I see where the other end falls. So I look at this and I say, okay, there's 0 feet. I have one end lined up. That really is 10 feet. That really is 20 feet. Mr. P said each one of these lines were 1 foot. That would be 21, 22 feet. There's my answer.
That is.
So they're not that hard to read. But for some reason, I get just either one invert or the other. I'll get somebody that'll tell me that's 2 1/4 feet, or they'll be back there doing math and trying to calculate it. Each one of those little lines represents 1 foot, add a 0 behind every number on there. So all I have to do is find the last one that I know what it is and count my way to it. Same thing here. Here's my 0. This one isn't written, but there's 10. Once again, they were saving some, only thing I can see, saving some money. There's 20, there's 30, there's 40, there's 50, 60, 70. So if I'm at 0 on this end, I come over here and I say, okay, here's 50, Those short lines, that longer line on this chart is the 55. So there's 55, 56, 57, 58. Oh, I missed one in there. 59. 59 feet. I don't need to see answers like 59 foot 6 inches because you don't know that. You cannot tell by measuring that line on one of those scales. Maybe this line right here goes a little bit past it. But Mr. P, look, it's right in the middle, so I gave you 22 foot 6 inches. Is that right? Yes. Is that what I'm looking for? No, I'm looking for 22 feet. Maybe 23 feet if it runs a little bit over. As your scale gets larger, my tolerance gets larger also. So whereas on the 10-foot scale, I might let you be one number on each side of what I measured. Runs through the copy machine, the printer, this and that. I might give you with one number off. But if right here on this one, you say, Mr. P, it was a little bit over the line, so. Nope. That's too far. You're getting outside my tolerance, outside my range of saying, you know, I'll give you half credit, or I'll give you full credit. If it's right there, I need to see probably either 22 or 23, as most everyone will see. It's when you get up to these right here, not this one so much, but when you get up in the 50 foot and stuff like that, that's where I've got a little bit bigger tolerance. Because I understand that you're holding it, maybe your eyesight, it might have been just a little bit off on the zero end. Now you're moving your head over, you're looking back over there, so, you know, it looks like from this angle over here, you're right on zero. But in reality, if you were to look straight down on it, you know, so I understand there's gonna be some variance in what I'll get back. But not that much, but it does increase as the scales increase. So that is what I want you to work on after a while and turn in tonight. So everybody understand that? Just to give y'all a idea of how it works, that first one, right there is the line that you measured. It has a column that says line. You can see there are different lengths. The next column right here, 1 inch equals. So that's like your scale. The first one is 1 inch equals 10 feet. So I'll go with that one. So I'm gonna turn my scale until I see the side that has the 10 on it. I'm gonna stick my scale on it, and I'm gonna measure. So those of you that have a scale, I'll give y'all a few seconds to try it out and see what you get. Now, if I'll stick my ball hand up there, if I remember correctly, I read 30 feet. Is that what y'all get?
Yes.
So just remember, you're not gonna have any super large numbers. I don't think you're gonna have any 200s, 300s, or anything like that.
I can grab mine from the triple.
Yeah, you can get it later, because I'm gonna start lecturing. I'd rather you sit in for the lecture part. All right, so any questions on that? All right, so on your border and title block for this course, I told y'all that I wanted y'all to go through and add some layers. I wanted y'all to go through and get it ready to be worked on. So when I gave it to you, it was just a raw AutoCAD drawing. Had some layers set up in it, had a border and title block for 24 by 36. Remember, you can change this viewport whatever size you want or need. Here's something else that I'm gonna need you to do for that course. For that border and title block. So on yours, you do not have all the scales set up. So when you open up AutoCAD, and y'all can just take notes and write this down. When you open up AutoCAD, you've got a lot of scales down here, but remember, these are all architectural scales. They all end with equals 1 foot dash 0 inches. Now, on your handouts that I gave you, that I put for you in Blackboard, one of them had on the bottom these engineer scales. Like I told you, engineer scale always starts with 1 inch equals. 1 inch equals 10 foot, 20 foot, 30 foot. Now you'll see this next column right here. At the top, I call it the scale factor. Down here on the engineering scales, the first one is 120. That is a multiplier for AutoCAD. Remember, when we do our drafting correctly, and we send it to the printer, that's where we should have text, 3/32 or 5/32 for our general text and our label text. Things like that, we need to make sure and come out correctly. Up until now, the biggest thing you had was your dimensioning, which as long as you did your drawings correctly, that was a fail-safe. So in here on the bottom down here on each one of these, they have that scale factor. Next to it, the next column, we know that's the one you possibly used a good bit with me. Printed text height, either 3/32 for general text, 5/32 for label text. Your N for your north arrow is considered label text. That would be an example of 5/32 text. So all of our drawings in the civil world are gonna have a north arrow on them. So that is one of your 5/32 text that you're gonna have on there. So when you come down here at the bottom, just like you see with the architectural scales, if I'm at 1 inch equals 10 feet, and I'm putting my text in that viewport, and I want it to print out at 3/32 height out of that printer, I'm gonna tell AutoCAD to make that text 11.25 inches tall. That way, when it shrinks down to fit on that paper size back there, 11 by 17, 8.5 by 11, 24 by 36, whatever size I'm doing to get it to print out 3/32, I'm gonna tell AutoCAD a text height of 11.25 inches. If it is label text, right over here in the 5/32 column, you can see that that text is listed at 1'6" 3/4. So remember, this is our printed text height that we want it to be when it comes out of that printer inside our viewport. 3/32 for just general text, 5/32 for label text, like your north arrow. And we'll talk about some more labels that you're gonna have on the drawing. So down here at the bottom, you do have those two columns complete. Your 3/32 text height and your 5/32 text height for all of these scales. You will not be using all of those scales, but since you don't know any better, now is the best time to go ahead and put them in. Here's how you add those scales into your AutoCAD drawing. The first thing you know that we have to do is to be able to see our scales down here on our status bar. The first thing we have to do is access that viewport. Remember, we're not scaling this border, we're scaling that viewport and the items that show up inside it. So to see those pop up on my status bar, I've either got to single click on that viewport or double click inside to open it up. That's for those of you that are gonna ask me in a little while, Mr. P, I don't see my scales, I can't set them on this drawing, or that email I'm gonna get. I'm gonna say contact Stuart and ask for video. Alright, so the way we set those scales up, down here in AutoCAD, as I said, we do not have the scales we need. In my classes, never use these ratio scales, for those of you that haven't heard that a dozen times yet. Our scales that we need are not shown down here, our engineer scales. If you're doing this inside your master drawing that's for several classes, whether it's mine, Mr. Spooner's, whoever, if you've got these border and title blocks all in one master drawing file, we're not gonna hurt anything for any of your other classes. We can delete scales off the list, but we're not going to. We're leaving all of those on there. My master drawing that I use for any and all of my classes. So if I were to come in and say, all right, we're gonna start a project, just like I recommend to y'all, I don't have to think about what class I'm in or anything like that. I haven't gone as far as I wish y'all would, but I do have the different all borders in one drawing. But if I open up that viewport and come down to my scale, you're like, well, that doesn't look nothing like ours does when I pop it up. I went through and said, I'm not gonna be doing any drawings that have ratios on it. All the people that I draw for either carry a tape measure or an instrument that reads feet, inches, or fractions. I don't do any electronic, the milling machines and stuff. I've never done any work for something like that. I can do it. I can just turn the inches off and draw a decimal if I do. So, stuff like that, these are the scales that I work with as a drafter. Not just the class stuff, but even out in the industry. If I were to go home and start working on a project tonight, and I open up my master drawing for architectural or something else that I'm drawing, my structural steel border, they've already got the scales and everything manipulated in here. So all of those scales that I deleted that you don't see on this menu, those ratio scales that I'm not gonna use, I took them off. I didn't affect the software, I didn't affect any other drawings, I just took them off this menu in this drawing alone. And then I went through and I added my engineer scales for my civil work. just like you see on that sheet over there. So that's my drawing saying I'm ready to draw anything. What class is this? Doesn't matter, I'm opening the same drawing. That's how I am in this classwork. So on this one right here, on yours, once you open your viewport and you pop up this scale scale tab, anything that you do in here is not affecting the software or your other drawings. It's strictly in this one. The way you will add those civil scales, these scales down here at the bottom. So you remember I said 1 inch equals 10 feet is a magic number or a scale factor of 120. If I come over here in AutoCAD and I pop this up, I'm gonna scroll all the way to the bottom, select custom off that menu. That's gonna pop up your edit drawing scales dialog box. Remember, we're just editing in this drawing alone. So I can go through there, I can take some of these and I can say, well, I don't want this here, let me move this down some. I use this one a lot. Let me move that one up. Put it up here at the top of my list. Remember, I'm only changing it inside this one drawing. The only one that you cannot delete off this menu is 1-to-1. You cannot delete that off of there. Everything else, your architectural scales, all of this stuff can be deleted from this menu. To add those additional scales, you've got an add button up here on the top right. You can see right below it, you've got an edit button in case you mess something up. I'm gonna pick the add button, which opens up my add scale dialog box. I'm gonna type in the name, just like your other scales. You want it to read what you're gonna put in your title block. 3/8 of an inch equals 1 foot dash 0 inches. 1 inch equals 1 foot dash 0 inches. Your civil scales in my eyes should be the same. So they all start with 1 inch equals. This one that I'm doing here is 1 inch equals 10 feet. So I type that name in. Maybe you say, well, I'm lazy, Mr. P, I'm just gonna put 10 feet in there. I don't care, I'm not gonna be checking that. What I'm gonna be checking is when you send something to the printer back there and you tell me it's scaled to 1 inch equals 10 feet, if it doesn't look right, I'm gonna put a scale, one of my scales on there, and I'm gonna check it. So 1 inch equals 10 feet is my name. In the box it says drawing units, not paper units. Paper units is still gonna stay 1. In the box that says drawing units, that is where your scale factor goes. We used to call it our magic number. We used to have to set up a dimension style AutoCAD prior to like 2009 or 10, somewhere. We had to set up a dimension style for each scale that we used. So just like we go through and set up our dim style, and we go through all those pages, making little changes that I do for you in your classes before we come in. We would go through and do that, and then we would save it, maybe 1/4 inch equals a foot. We would put that scale factor in there, that magic number. And then we would open that one up and we would do new. When we picked new, we just made sure that one was lit up. All we had to do was go change that scale factor, that magic number. And boom, there was our new. But we had to make a scale for each one, for each scale we used. Nowadays, we don't have to with AutoCAD. As long as we manage our viewport and do our stuff correctly, it's a fail-safe. And doing it correctly is just like you would do it out in the industry. So for this, to set up these new scales, we do have to put in that scale factor. So where it says drawing units, I'm gonna type the number that is there. Now, those of you that have had me for classes before, you've heard me talk about how I'm a math person. My brain works in math ways. It took me calculating a couple of scales before I said, damn, dummy, you just multiply the number of feet times 12 inches. That's the magic number, that's the scale factor. But I mathematically calculated a couple before I figured out what was going on. So for you, it's on that chart. All you have to do is go through and type in the name, put the scale factor in the drawing units, pick OK. Add another one, 1 inch equals 20 feet, 20 times 12, 240. You need to do that for all of those scales. So everybody okay with that process? After you get through, like I said, you can manipulate this list, how they're shown. If you're doing strictly a civil drawing, you say, well, I want to put this one on top. You can click it, move up. Click the other one, move up. And you can position them and sort them however you want. All right, so on to the next. What I'm going to do now is I'm gonna give you your instructions for your first project. Here's some more homework for you. Chapter 1, Part 2, and Chapter 5. Now, if you looked at Blackboard, you saw by dates that first thing it's wrong. Because we made these dates back in November or December or something like that, before we knew that we were gonna be canceled for the first few days of school. So, that right there is still pretty close, but we're not fully on that schedule that's in Blackboard. But if you look at it, you will see that the project that we're about to do, which by the way, the title is called Sports Complex. That's your title, Sports Complex. So the project that you're fixing to get the information on, Sports Complex, is gonna be on a 24x36, but it is a 2-week project. So when you come in a week from tonight, I expect you to have a good bit done on it already. And then I can help you and we can talk through finalizing it. So it's a 2-week project, but don't wait for a week and a half to start it. All right, so on this project, what I'm going to be doing is I'm gonna be giving you some information about that project, the specs, the data that you need for that project. Like I said, it's called Sports Complex. It's gonna be on 24x36 border and title block, which is the one I put in Blackboard for you. In your civil classes, unlike stuff like pipe, architectural, structural, we do not have a standard scale in civil. So your rule is, just like back in first basic CAD class when you started working with viewports, the rule is as big as it can be. So if we can put it at 1 inch equals 10 feet, we're not gonna put it at 1 inch equals 30 feet just because that's what scale we already have the viewport set to, where we got half a drawing around there that's bare, and then a drawing that's cluttered possibly in the middle of the page. You will not go smaller than 1 inch equals 10 feet. So if you end up 1 inch equals 10 feet and it still looks kind of small in your border and title block, check your scale to make sure, maybe look at somebody else's and see if theirs is small too. But don't go through and build another scale, 1 inch equals 5 feet or 1 inch equals 2 feet. Stay with the standard scales that I put on that drawing factor sheet for you. So once again, your scale is gonna be the biggest as it can be. All right, so what you're gonna be doing for your first project is you're gonna be drawing a property and a road that runs by it. I'm gonna give you some info on that. The last thing I'm gonna give you is the sides on drawing the property, and then we'll talk about that. So it's gonna be a sports complex. On your property, you will be designing for a customer that comes in and says, I've got this piece of property, here's my deed, here's my plat for it, here's all my measurements, here's the road that runs by it, you can go out there and look at it all you want, there's nothing on it, I want a sports complex. And so we said, well, what do you want on that sports complex? First thing they said was, I want a football field. Now, if you go back to a document that I handed out in Blackboard to you, this was the sports standards document. You can't see all of it over on that side. I'm gonna get them back. Where you at? They're gonna hate me again. I'm gonna have to get him back over there. A lot of it, I think, is set up there. He messed with the computer itself, changing the pixels and stuff, but I just noticed it's cutting off the right side of that screen over there. I'm gonna have to get with them Friday and get him to come over here and look at it. And I think in 101, they said, Conchava said he was having some of those issues too, so I don't know if he sent a ticket.
I think that's been fixed today. Cause I was sitting in there, he came in and then.
Yeah, I know he had a problem, but this is the first time I noticed that the right side was getting cut off. And unfortunately, I can't do anything other than minimize it to help bring it back over possibly. But now y'all can't see crap, so we'll see what we can do. All right, so right here on the left side of this handout that I put in Blackboard, you will see it's labeled football field. These are the measurements for your football field. So the actual field, not everything that you're gonna be getting shows up on your drawing. So in the civil world, if you look at a drawing in model space versus the printed out copy, you're gonna be like, wow, there's a lot of data on that drawing. There's a lot of stuff drawn on there that did not make the final cut. We do that a lot, so you have some layers that are no print layers. You have your VP or viewport layer, you have your reference layer, that are on that sheet that I put for you in Blackboard with the layers, so put those on there. Feel free to make any other ones that you need. Stuff like easement lines, we're gonna have easements that we're gonna be dealing with on this project that we don't want to print. But we need to be able to see them while we're working, because if they say you can't go in this area because there's an easement there, and you design a project and you've got, a football field, you've got a track, building right there on that easement, you just killed the project and really made yourself look bad. Oh yeah, God, I had that, but I knew it didn't print, so I erased it, and I forgot to look at it. There's no reason for that. We have no print layers. We can freeze layers in viewports, stuff like that say, I need this data shown on the drawing so that I don't infringe on that. I don't do something that I shouldn't do. Stuff like that you're gonna see on here is what we're gonna be talking about. So you will see that the football field is the dark line that is 360 feet by 160 feet. I've got those measurements. Around the outside of it, I've got a rectangular, and you don't have to put the yard markers. You can go to as little and as large of an extent as you want to on your football field. I've had people go through and put their favorite high school or college or pro team in the end zone, that name, and do yard markers and do a lot of work on the football field. It might look good for the customer or the client. They might like that. For this one, I'm telling you, you don't have to though. So as a minimum, you need that rectangle around the outside, 160 by 360 feet. And then the dashed line around that is a no print. That is your buffer zone, your do not get in this area zone. That's for the teams, the band, the cheerleaders, everybody, the managers. That's where that's at inside there. Kind of small, but we're gonna go with that. So all the way around there, 15 feet, I would recommend you just draw a rectangle for the football field, offset it 15 feet to make sure that you don't infringe on that easement. Now, easements can overlap. So your tennis court, your basketball court, I'm not giving you any info saying that you're gonna have those on this project. We'll talk about that next week. But you will be having at least a couple of these alternates on there. You're gonna have a football field with a 15-foot easement around it. If we go with tennis courts this semester, same deal. All I need is the outside rectangular, the 36 feet by 78 feet or whatever that is, with a 15-foot buffer zone around it. Basketball court, 94 feet by 50 feet, if I get y'all to draw or have those on there. Once again, 15 feet buffer zone all around. The only thing that you can encroach on that 15-foot buffer zone with is another 15-foot or another easement or buffer zone. We're gonna have sidewalks and stuff that we're gonna go across this, but we're gonna try to keep that stuff at a minimum. So your basketball courts or tennis courts, whatever I give you to have on there, are gonna need a sidewalk leading to them, a 5-foot sidewalk around the outside of them. These two right here. Wait till next week and I'll give you those. But they will all have that 15-foot buffer zone or easement around them. So right now you've got a football field that you could be working on drawing with the easement around the outside. Down here at the very bottom, you've got a side view of some bleachers from a bleacher company. Your bleachers are going to be 90 feet long. This is the side view of them. So each one of these little seats are gonna be 90 feet long. Just like your football field, I'm okay if your football field is just a rectangle. I'm okay if I give you tennis courts, basketball courts. I'm okay if it's just a rectangle. Your bleachers, if you try to go into detail, if you try to draw your bleachers, remember we're talking about a plan view, and you try to draw your bleachers outside your 15-foot zone, next to your football field and stuff, and you try to draw all those lines, it's just gonna come out like that. Just like your other stuff, all we need are outlines, profiles of these objects. That's what we need, especially with the bleachers, because like I said, it's gonna blur together. So on your football field, just to blow that up a little bit, here's your football field. Your bleachers, we've got that 15-foot easement that we're not gonna infringe on. You can go right up to that. You will need a 5-foot sidewalk accessing your bleachers. Once again, not inside that 15-foot buffer zone. Now, all of the items on your facility are gonna need 5-foot sidewalks accessing them. We're gonna talk about the parking lot in a moment. You're gonna be bringing a 5-foot sidewalk from your parking lot, 1 or 2, whatever, 3, whatever works best for your project. And at some point, it's gonna branch off or go to each one of these, items. The football field and any basketball or tennis courts that y'all have will need a sidewalk accessing it. Those sidewalks need to be 5 foot wide. That is ADA standards. So your football field is gonna have your bleachers out here with a 5-foot sidewalk, just a rectangle member for your bleachers. And your sidewalk coming around that football field, maybe coming over here to your parking lot. There's your bleachers right there, so that sidewalk continues onto the parking lot. Here's your football field. Here's your buffer zone coming around the end. You can bring that sidewalk right along that buffer zone all the way to the other side to your other bleachers. Same thing, just run it across the front of them. So your bleachers come to here and end. Your football field, well, that would be just the buffer zone now. You can have your 5-foot sidewalk come to this end of the bleachers and come across. Maybe they meet up out here, maybe your sidewalk ends right there. It's your design. So this is what the customer is saying that they want. Whenever I give you your basketball courts and our tennis courts next week, I'll tell you how many of each they want, just like a customer would come in and say, oh, this project that I gave you last week, I decided I wanna add this. So it's gonna be a real life kind of thing, situation on this, a design project. So on your bleachers, I'm not gonna add any, usually I'll add 1 or 2 rows up here and make you calculate how big that rectangle needs to be. So we'll just stick with 3 rows this semester. So your rectangle is gonna be at a minimum 5 feet by 90 feet. Does everybody understand that? Remember, we're looking down on it. We're not gonna show all of the seats. We're just gonna show the outside. So if we were looking at that rectangular shape, that outline, that profile of those bleachers, it would be 5 feet by 90 feet. On each side of your football field, not on the tennis courts. If you wanna stick some stuff over there, you can. The stuff that I'm gonna be giving you is more of a minimum, you know? So if you wanna stick some stuff over there, stick some bleachers by those, stuff like that, you're more than welcome to. I just may ask you, hey, what's this box right here? Oh, that's the bleachers for the basketball. Oh, okay. Cool. I just needed to know. You had an extra box on there before I rung it up. I wanted to know. All right, so any questions about your bleachers? In this area, you will see all of your parking scenarios. If you have some parallel parking, there's your design for that. They need a minimum of 20'6" curb to curb if you've got curbs there. If not, still need to allot for that much space for those parking. The parking spaces are 8'6" wide, 24 foot long. And you need at least 12 foot to be able to parallel park into those spaces next to it. So once again, maybe yours has some on the outside. Maybe, I'm gonna give you your number in a minute, but maybe you counted and you were 4 short of how many parking spaces the customer said they wanted. You could just throw some of these along the side somewhere, wherever it fits this design, boom, there's your extra spaces. If you choose to do your standard 90-degree parking spaces, so you're going to be designing a parking lot, and I will give your quantities in a moment. You're gonna be designing a parking lot that has to meet these standards, and yes, I will put a scale on there and check this. So if you have 90-degree parking, which is the easiest parking there is, the least amount of errors on the work that I check, the parking spaces themselves are 18 feet deep and 9 feet wide. When you start drawing this, just like the football field, I need your heavier lines outlining the concrete. Your lines for your parking spaces, you can do those in like the dimension layer. I still say keep your layers as many as you need, use them. You could make a layer called the paint layer that has like a 0.3, 0.2 millimeter line weight, something light, because object lines, edges of concrete, edges of sidewalk, edges around the football field, edges around the tennis courts, the outline of all of those are object lines. We're considering this just paint on the parking lot. So you will need to show all your parking spaces, but once again, you will not be showing dimensions. I will be measuring to see if they meet the dimension standards. So if you do 90-degree parking and it's one way, or just one lane of traffic right here, 18-foot parking spaces, 24 feet behind it to be able to pull in and out of that space, you need a minimum of 42 feet for one-sided parking spaces. That also carries over, that 42 feet also carries over to your handicap spaces. The 18 feet and the 42 feet also carry over. Right down here below it in the 90-degree parking area, this is if you've got parking spaces on both sides of the drive. 18-foot parking spaces on each side, 24-foot behind them to pull in and pull out, still 9-foot wide spaces. Everybody still with me? If you decide to do 45-degree parking, if you got one lane traffic and one side parking, your parking spaces, remember this is 45-degree lines, so you've got 45-degree lines that are 13'5" off of the curb or the end of the parking space. You need 13 feet behind them to be able to pull in and out of those spaces for a total aisle width of 26'5". If you've got both sides parking still one-way traffic, here's your dimensions to be able to draw those 45-degree parking spaces. If you've got both sides parking, two-way traffic, here's your design criteria. If you use the other option, which is 60-degree parking, 60-degree one-way single side, 60-degree one-way double side parking, 60-degree double side, double direction parking. So any questions on the design for your parking spaces? Any questions about this information right here you don't understand? Anything on this page? I'm gonna back up a little bit and see if I have the handicap spots on here. For some reason I don't. I thought I'd added it, so I'm gonna have to go through and fix that.
Handicap's at the top near, should be to the right of the basketball court.
Yeah, the one that I put in there, that's what it is. The one that I put in y'all's blackboard is correct, man.
Yes.
So let me open that puppy up so we can talk about it. That was still the one from the old 2330 class. Yep, there it is. If any of y'all live out in the Finette area, Craig and Boyd lost, one of his dogs took off last night. So if y'all see a skinny beagle running around, tricolor beagle around the Green Acres area, his name's Colton. Cragen, if you want his last name. Kinda sucks, he came by and bought the dog from me yesterday. I get a call from him at 6 o'clock this morning. Hey man, she took off last night, she dug out of the kennel. I was like, damn, no shit. He goes, yeah. He goes, I'm gonna go ahead and come by the other one too, maybe she'll come back if the other one's in there with her. I was like, yeah, she's been around her sister, they're about 1.5 years old. I said, yeah, she's been around her sister since she was born, so if you can keep the sister in there, the other one might come back. But, so if any of y'all know anybody in the Finette area comes across a Roman Beagle, either email me or it's Colton Cragen, who it is. So,
Have they posted it on Facebook yet?
yes. Yes, he did, and then, my kids have also posted some stuff, and they talked to people out there, friends of theirs that live in that area too. Alright, so this is your handicap parking spaces. The handicap symbol itself can easily be found by Googling, and then you can just do a screenshot, put it on your drawing and draw. I don't trust blocks, downloaded blocks. I've got some that I've downloaded, but I don't recommend it to y'all unless it's from a very trusted source. So your handicap parking spaces, each one of those are gonna be 2 spaces Now, I don't show it on here, but this is where the curb would be. So I need to draw that line on there and redo this PDF. So your curb would be running across the top of this design right here. So your drive-in space would be behind it.
Well, technically it would be an up ramp because handicap.
No, we're just talking about parking, there's no ramps here. Yeah, we'd have a ramp somewhere, but just right now, we're just talking about parking. No, y'all don't have to worry about ramps and stuff. As far as y'all know, everything's flat, parking lot, sidewalks, everything.
Right.
So on this one right here, on the left-hand side, this is the actual vehicle parking area. You can see that this is one handicap space. Each one of these spaces are 8 foot wide. Remember, all of this is gonna be done in a thin line weight. This is not in your object layer, this is paint on the parking lot. Each one of these 2 spaces are 8 foot wide, 18 foot deep. The one on the left is for the vehicle to park at. You will need to put a handicap symbol on that side. The one on the right is for van accessible. You will need to show those lines to illustrate that that is not a parking space, that is a handicap van accessible area. All right, so everybody clear on that?
Was that count for 2 parking spots?
No, that's just one. That is all one handicap parking space.
Are you gonna give us a specific amount of handicap?
Yeah, I'm just to tell you, don't put a handicap on the other side and just that one hatched area in between them and count that as 2, because this one on this side still needs that hatched area for the van accessible. So it's always on the right or passenger side of the vehicle.
Can you flip flop them to where like on this one, the handicap sign is on the left? Can you put them side by side and have the 2,
No,
where the handicap sign?
so you're pulling one in from one side, one from the other, don't do
Yeah.
that. Don't do that. Cause now you gotta have that backside space and you gotta have drive-through, whereas all these other ones need a curb. You're just adding a lot more work for yourself for no reason. So it would have to be flip-flopped on the other side. No, don't worry about it. Don't do that. No easy routes in my class. You ought to know that by now. Alright, so any questions about anything on this document? Alright, here's the specifications for yours. Your drawing will have a 15-foot easement inside the property line. The only thing you're allowed to do on that, across that easement, is to put a drive from the road, or driver drives, however many entrances and exits you have when we talk about that. That's the only thing that can cross that easement. Your buildings can't be on it, your sidewalks, your tennis courts, none of that can be on it. Mr. P, can that be counted as our buffer zone around our football field, around our tennis courts? Yeah, I'll allow that, as long as it doesn't have something like bleachers in it. If it's just outside your stuff, and you show that rectangular shape, I'm okay, once again, with this easement overlapping those, on this case. We never know what those easements for, they're usually spelled out in the deed. Lots of times it's like drainage. Yeah, on my property, I've got 3 easements across it for pipelines. And trust me, they fly those pipelines. They let me know within days of the time that I had a big old Connex brought out there and put out there for storage. They let me know within a matter of a couple of days that I was in a violation. I had X number of days to move that, or they were gonna haul it off for me. Yeah. If something happens and they need to go out there and dig in there or something, I was okay putting my chicken coops and stuff like that,
Right,
with a
not
roof and
permanent
stuff,
structure.
some kind of temporary structure, but like they said, we're okay with that. But if we come out here, you better get your chickens, cause all we're gonna do is drive something through it. Not a problem, buddy. So, yours has a 15-foot easement on the inside of the property line all the way around it. Your property will have a 40-foot by 60-foot field house. You will need a sidewalk leading to that field house if you wanna put a sidewalk all the way around it. If you wanna make it bigger than 40 by 60 and have a concession stand out the backside, you're more than welcome to go above and beyond. Just don't go below the information I'm giving. You will have 2 rows of bleachers that we talked about, 90 feet long. Your parking lot will be for 100 vehicles, 100 standard vehicles. Now, when you show your parking lot, so you're gonna have a property line on the bottom side down here. You're gonna have a road that we're gonna talk about that is outside of it. And then you're gonna have that easement 15 feet all the way around your property line on the inside that you're not gonna encroach on. Once again, you can use that for a concrete edge, so you can bring your drive. Maybe you bring yours up and you tail it off over here. And you've got parking spaces along it, that's allowed. Do not give extra concrete. So don't just go through and concrete everything and say, yeah, Mr. B, here's my parking spaces over here. You need to adhere to those standards that I gave you. So maybe you've got some parking spaces over here along this side. You got some parking spaces out here in the middle. If it says 30 feet between these two, it needs to be 30 feet. If it says 24 feet, I think is the minimum behind this parking space right here, 24 feet is what I wanna see. I don't wanna see a bunch of extra concrete. So I'll have students that'll go through and just make this big ass parking lot with just parking spaces right there in the middle. That's gonna be points off. So we're trying to save stuff like that, and reduce cost. So your parking lot is for 100 standard parking spaces. You will have 8 handicapped parking spaces. So remember, each one of those on that drawing is 1 handicap space. You will need 8 of those. On the road. So your property, from memory, is shaped something like this. Your road is down here on the south side of that property. Now, if you offset your road out, just remember to extend those lines. What I usually do is I click on it, and I click on that midpoint right there, and I go to scale 1.5, just to make it longer. And then what, because it doesn't end at our property, don't imply that, don't just offset it and have all these lines ending right there, looking like the road ends there. So you're gonna have a road outside of your property. Remember, these are property lines. Which I think I put that one in Blackboard for you. So on the south side, you will have a road that is 10 feet off your property line. Then you will have a 15-foot shoulder, a 15-foot lane, another 15-foot lane, and another 15-foot shoulder on the other side. So offset your property line 10 feet, that'll be the start of the shoulder. Then it's shoulder, lane, lane, shoulder, each one of them are 15 feet wide. Anytime that you turn with your drive, so we have vehicles coming in, turning this corner. If we had vehicles going that direction, we'd have to have that arc right there. We don't want them dropping off the concrete. So you're gonna break that, that shoulder line right there, bring one or however many entrances you have to your parking lot. You bring them across, you're gonna have a 15-foot radius arc right there, a 15-foot radius arc on that side also if you're turning both ways. If you get up into your parking lot, and I've had students, you don't have to have just one parking lot. I have students that have a parking lot, they have some more back here, they have some over here, maybe by the field house for the coaches to park and stuff. A minimum of 100 standard parking spaces, a minimum of 8 handicap parking spaces. Now your handicap parking spaces always need to be nearest the facilities.
Of course.
Okay, so you're gonna have those 5-foot wide sidewalks. There should be a sidewalk right there by your handicap spaces and nearest the facilities as you can. So once you say, all right, this is where my football field's gonna be, you know, anything else, tennis courts, field house, any of that stuff, here's where I'm doing my parking lot, the road's on the south side. You can do your parking however and wherever you want, just so long as you follow those standards that I put in Blackboard. All right, here are your property dimensions. So remember, we're in the civil world now. You're not gonna be getting numbers like what you're used to. Am I ready to write? What I'm going to be giving you is the length for the side and then the angle for the side. So in here, we're going to be using surveyor's units. Some of your definitions that I gave you earlier, your terminology, talks about bearings, talks about azimuth, ways of telling someone a particular direction. Bearings that we're going to be doing work in 90-degree quadrants. All of your angles for your properties are gonna start with either a north or a south. They will all end with either an east or a west. So to give a fairly easy angle, if I were to put the angle north 45 degrees east. Similar to some of the older AutoCAD, if you've had me for AutoCAD classes, and I gave you those little charts with 0, 90, 180, and 270, I said anytime you're drawing, visualize yourself right there. If you draw a line and you're drawing, now you're down on this endpoint, visualize that over there. You draw that line up, visualize that over there, 0, 90, 180, 270. Learn it, visualize it. Same thing with your civil. So north 45 degrees east. If I say, okay, you're out there, maybe they're standing at the starting point and they're fixing to lay out this property. And I'm telling them how far to put the next property in. I'm gonna give them a distance and then I'm gonna give them a direction. What they're gonna do is they're at that point, just like in the other classes, you're at the center of this one. They're gonna face north and they're gonna rotate to the east 45 degrees. That's what that angle is telling us. Azimuth, you'll find that on some stuff that you go look at. It's not used in most of the stuff around here on like properties, plot plans, plats, they call them. When you look up deeds and stuff, it's given in surveyor's units. Normally in bearings like this. Azimuth is kind of like what we grew up with. That AutoCAD said, no, it's not like that anymore. Zeros to the right. We count counterclockwise. Azimuth says north is 0 degrees and you count in a clockwise direction. So instead of something like that, I could tell them in azimuth, go to 273 degrees. 0, 90, 180, 270, 273 degrees would be that direction in azimuth. We're not gonna be getting our angles like that. Our angles are gonna be in what AutoCAD calls surveyor's units. Always starting with north or south, always ending with east or west. So what I'm gonna do is I'm gonna give you these measurements for your property, and then I'm gonna show you how to use those measurements. So your first property line, distance 410.65 feet, 410.65 feet. Another note, I don't remember if I told y'all this last week, but we're not gonna go more than 2 decimal places. So it's not really gonna apply on this project, because that's as far as our numbers go anyway. But as we progress through this class, just keep that 2 decimal place max. Anytime that we have something that's more than 2 decimal places, and remember that counts for your, that document I put in Blackboard, decimals of a foot, it goes to 4 decimal places. So if we're working on something, you're pulling a value from there, you're only gonna round it to 2 decimal places. So 410.65 feet, your direction, your angle for this line, south, 8 degrees, 16 minutes, 18 seconds east.
Okay.
The way we write that, south is just S, because we know we have to start with either N or S, north or south. 8 degrees, when you put it on your drawing, it's gonna be 08 degrees. When you go to type it in, remember, there is no degree key on your keyboard. for you to write that, which remember, we're not doing dimensions. You're not gonna, click on your angular dimension and AutoCAD's gonna pop that angle on there for you. It's gonna be typing those numbers in. So when you go to type it around your project, you're gonna do, percent D, which will get, actually, I should have wrote it right here. That'll get that symbol, that degree symbol to pop up when you're typing it in. So if I'm typing this in and I'm telling AutoCAD to draw that line, I'm gonna type it in as S08D. Don't label your drawings with that though. So it's south 8 degrees, 16 minutes. Even if it is one character right there, always show 2 for your degrees, minutes, seconds. So just like I wrote 08, not 8, always show 2 characters for your degrees, minutes, seconds. South 8 degrees, 16 minutes, 18 seconds, east. That is how that number would be labeled on your drawing. To type it in, it's S08D, 16, and then your foot mark, which is the minutes, 18, and then an inch mark, and then E. And like I said, I'm gonna draw some of these for you in a minute. So however you write it down on your notes to write down these measurements, that's how it would be written out normally. So that one was south 8 degrees, 16 minutes, 18 seconds east. Your next side, 600 feet even is your length. Your angle is north 73 degrees, or excuse me, north 73 degrees, 52 minutes, 39 seconds east. That's north 73 degrees, 52 minutes, 39 seconds east. Your next side, your distance is 450, 450 feet. Your angle is north 23 degrees. 16 seconds, or 16 minutes, excuse me, 18 seconds west. North 23 degrees, 16 minutes, 18 seconds west. Your next side, 350.31 feet. 350.31 feet. Your angle, south 81 degrees, 43 minutes, 42 seconds west. South 81 degrees, 43 minutes, 42 seconds west. Your fifth side you will have to find. You will close that shape. So, on your drawing, what I've got opened up here is just my general master. So it's got all of the different layers and everything in it. So using your sequence sheet that I put for you in Blackboard, I would open up my master drawing, Control-Shift-S for my save as, doing a property drawing. So the first thing I'm gonna do is change to my property layer. Now I will be using the relative polar coordinates formula. At the distance is less than the angle. If I type in UN and spacebar, you can see that my angles are still set to degrees, minutes, seconds. Unlike your length measurements, your angular measurements in AutoCAD are fluid from one to the other. So I can come down here and switch to surveyor's units, because that's what it is I'm putting in. North or south at the beginning, east or west at the end, but it won't matter. I'm gonna show you that. So I'm still set to degrees, minutes, seconds for my angular measurements. I usually go into my polyline to draw these, because you will be calculating area on your properties. Now, once you start doing stuff inside there, lots of times I'll explode it, but I usually put it in as a polyline just so I can measure my acreage. You're more than welcome to join it together later on, or do your acre, measure up here, your area measure right here. You're more than welcome to do it any way you want, but you will be calculating area. So to draw my property line, I'm gonna type in PL for property line. Any of y'all believe that, y'all need to go back to 1309. Alright, so I'm in my polyline command. I'm gonna move my cursor down here to the bottom right because I have no need for it. Everything's gonna be keyboard entry. I'll see people that'll start drawing, they're rolling their mouse real back. Mr. P, it won't let me zoom out. I gotta hit escape, zoom extents. No, you don't. Wait till you finish drawing it before you do zoom extents. Don't worry about trying to see that last point you picked in. Trust your tool. If nothing else, look at your command line before you hit enter and make sure you type the right thing in. Other than that, you do not need to see all of these corners. So let me see what distance I'm at. I'm at 91 feet. Let me see. 2 foot, yeah, that'll work. All right, so my first side, I picked my first point. Like I said, I'm in my polyline command. Our relative polar coordinates formula at the distance is less than the angle. So I type in the at symbol. My distance for this side is 410.65 feet. Is less than, so the formula at the distance is less than the angle. I did the at symbol. Students frequently forget that. I did the at symbol, I did my distance, and I put the foot mark on there. Students frequently forget that. And then the next thing in the formula is the less than symbol. Same key as the comma key, I just hold the shift key down. At the distance is less than the angle, which is south 8 degrees. So you can see that I typed in S8D. Because once again, there is no degree key on here. The D is telling AutoCAD this is degrees. So S8D, south 8 degrees, 16 minutes, which is your foot mark, 18 seconds east. Once again, I'm not labeling that drawing, I'm drawing that side. If I were labeling the drawing, I'd have some more things I'd have to do, the degree symbol instead of the letter D. Some of y'all's gonna put it on there. It's okay, I got a red pen, got plenty of them. Mr. Spooner stocked me up right before finals last semester, I got a couple left. So I look back over at symbol, less than symbol, so my formula symbols are there. 410.65 feet, that number's good. South 8 degrees, 16 minutes, 18 seconds east, that number's good. I hit enter. Mr. P, I can't see where that line went, that's okay. Once again, at the distance is less than the angle. At 600 feet is less than my angle, north 73 degrees, 52 minutes, 39 seconds east. Maybe I looked at it a little bit more, but make sure. If you're not sure if it's drawing the right line, or if it doesn't draw it correctly, pan back a little bit, shrink it down, move it over a little bit, and draw it again. Don't erase the first one. Move over to some clear area, draw it again. Get better with your tool. Get better with working with your tool. You're not gonna get that by just drawing this every time one of us says, hey, you need to do this work and turn it in. You're gonna get that way by spending time in the software. This formula I'm using should not be something new to you, even though you probably haven't used it. But if you had any of my CAD classes, you were told to use it and abuse it. Play, 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 practice, practice, practice. Don't wait till you need to use that tool to have to do it. Don't wait till you get a flat tire to see if you have a spare. If you have a jack, you should know where that stuff is. My next side, once again, at my distance, 450 feet is less than my angle. North 23 degrees, 16 minutes, 18 seconds west. I'm gonna check this one just to make sure. Hit enter. Next side, at my distance, 350.31 feet is less than my angle, south 81 degrees, 43 minutes, 42 seconds west, and then C to close. And then I'm gonna double click my mouse wheel and see what I got. Now, whenever you go to do this, at this point, if you've got some paper handy, while you click on it to make sure everything's locked in together, you can go ahead and come over here to your properties dialog box. If you hover over that area section, or if you want to, you're more than welcome to drag it out to your workstation. So if you say, well, I don't wanna have to do that, I wanna be able to drag it out, you can drag it out to where you can see it. The first value in area is not square feet. The first value is square inches. Do not use that number. The second value in parentheses is your square feet. That's the number you need to use for the conversion. So it's 250,638. I'm gonna forget that, and I'm just gonna Google square feet. Look, I didn't even have to hit the F. Once I hit SQ and space, but I've been to it on this computer before, there's my square feet to acres right there. I click on that, Google opens up its calculator. I can simply type that number in or copy it from over there. I'm gonna go 300,000. There's my acreage right there. I'm gonna look at that number and I'm gonna say 6.887. I round it to 2 decimal places, so I'm not gonna show all of this, but to round it on my drawing, I'm gonna put 6.89 acres. Everybody good with that? Back to my drawing. So now I can explode it, do my offsetting for my property line, for my, I could offset for my easement first, probably would have been better. But for my road, I can offset that, I can click on it, like that's what I told you I usually do. Scale 1.25, something like that to get it outside the property line. And then offset 15 feet. Shoulder lane, lane shoulder. Your regular layers like object layers and such can still be used. Those are not property lines, they can be used as an object line. These two also. This one is the center of my roadway. We're not gonna use a center line. Remember, those of you that have driven on a road or rode on a road, you know it's not a long dash, short dash, long dash, short dash. It is a hidden line type for the lane. So you can go through and start building your drawing based on that. What I recommend you do for your football field is you just pick a point over here to the side. And then put it on your property and rotate it as needed. Now here's something that you may not do. I'm gonna offset that for my easement on the property line, even though I've already exploded it. I'm gonna go ahead and offset it and put those in there. I'm gonna change them to a different layer so that visually they look different to me, but they're also not a printable layer. I'm gonna switch them to that so I'll look at them and see them pretty easy. So, if you say, I want my football field to be parallel with that property line, I'm going to first move it over there. The two ways that I do it, depending on what I feel like sometimes, or depending on which way I wanna do it. So here are 2 ways that I can get that position straight along that property line without, and drawing it 90 degrees like I did, horizontal and vertical, is so much easier than doing all that offsetting and trimming to use your property line to draw it. You're wasting time. So I can go in either my rotate command, RO and space bar. I can select that object and then tell it this is my base point. When AutoCAD says specify rotation angle, I'm gonna select reference, one of the options down there. Then I'm gonna tell AutoCAD take this endpoint, which is gonna stay right there, and then take this endpoint and align it with that intersection, that endpoint, something like that. And AutoCAD will rotate it to match it. Another way you can do that is the align command. To do the align command, it can be anywhere. I can go AL and space bar. AutoCAD says select the objects. I can say this object right here. AutoCAD says first source point. I'm gonna pick this midpoint here, this midpoint there. Second source and destination, that endpoint, that endpoint. I'm gonna hit enter for third. If you had me for intermediate CAD, you already had this. AutoCAD says, do I wanna scale it? I'm gonna tell it no, which is the default, so I can just hit space bar. And bam, there's my football field in line with that property line. I can say, well, I need to move it off from my bleachers, my sidewalk, not a problem. My easement, got all that right here, plenty of room. So however you wanna piece it together, understand this project will be completed 2 weeks from now. You know that you're gonna have a drive coming off of this area. You know you're gonna have a football field and a field house. You know you're possibly gonna have some tennis, or you're gonna have some tennis courts or basketball courts. So you could just draw the bigger of the two, or you could just actually make up some rectangles, one for the biggest and one for the smaller of the two. And you could go ahead and start putting a couple of those on your project if you want to. You've got all the parking lots you can work on. You got plenty of stuff to work on this project in the next week. So I've got some more information to give you on that project, but we're gonna wait till next week for that. I'm gonna go ahead and cut loose now. Any questions over that?
One quick question.
We're already past the question, Jay.
You just said.
Okay.
Okay, so
Way too soon.
eventually, based on next week, is the football field, the basketball, and all that gonna be on the same property?
Yes, everything's
So
gonna
we need
be.
to make sure to leave room for those
Right,
things.
yes, so that's all you're doing really for those. You don't know what it's gonna be. It's like I said, if you're gonna have at least two of them, I'll tell you that.
Okay,
Not one of each, but two of something, two of one of those. So if you wanna just pick the bigger rectangle and go ahead and do your whole property based on that from now to then. And that way, next week, if I say, all right, instead of that one, it's the smaller one, you just downsize your rectangle a little bit.
Another question, Mr. P. For the drawing units, did we change it from architectural? Did we change anything in the, drawing units window?
Drawing units window, that pull up, don't worry about the architecturals, you can delete them if this is strictly your civil drawing, but, you know, you never know, I might be weird and throw something at you in these dimensions.
Okay, so we don't
Needs
need to
those
change
scales,
anything
yeah,
in
just
that
leave them in there,
outline?
but if you're making a drawing that is just for your civil class, I recommend after you add those additional layers, you move them up to the top,
Okay.
cause that's the ones you're gonna be using in this class. You'll still be doing the text 3/32 or 5/32. So your measurements around the outside, we'll talk more about labeling it, your legend and stuff like that next week. But don't forget your two standard text heights, 3/32 and 5/32. That does not apply to your title block, by the way. That is 1/8 text. Go figure. Alright, so any questions for right now about that project? Like I said, next week when y'all come in, I'm gonna have some more work for you, but next week when y'all come in, we'll talk about that project first thing. We'll do some lecturing on it. I've got some stuff for you, some more information on it. So y'all good on that for now? Enough to play with? Alright, some other assignments that you've got for take-home assignments. Chapter 1, Part 2. Some of your chapters, so the ends of the chapters in this textbook are not like your other textbooks. It doesn't just say, all right, chapter's ended, here's the review, here's some exercises, move on. No, it says here's the review, and you flip the page, there's review part 2, there's review part 3. So whenever I give them to you, some of them do not have a part 1, 2, 3 that you have to worry about. Some of them do. Anytime you see those questions that are multiple choice questions, that is the part that I'm getting you to do. But always verify with me, it won't hurt. So chapter 1, when you look at chapter 1 at the end of the chapter, you have something, I think it might say review part 1. We're doing the review part 2, which is 10 multiple choice questions. Chapter 5, on the other hand, when you look at it, don't go, oh, he must have said a different chapter. There's no multiple choice questions. No, there isn't. Chapter 5 review is like 26 questions, I believe, and it's typing up, not writing, typing up the answers. So it's kind of like what it was in the basic pipe class, where you have wordy type answers. So on your chapter reviews, put that document in Blackboard. It is a downloadable Microsoft Word document, which we have up here. So I'm gonna let y'all take off with the scale in a minute and work on those. But Use that or make one similar to it. Remember, as a minimum, I need the answers. So the A, B, C, or D as a minimum. If you want question and answer, go ahead and put it on there. I'm okay with that. As a minimum, I need that letter, the A, the B, the C, or the D. If you feel better putting A, hydrostatic or quadrangle, whatever the answer is, you can type all that out you want, as long as I see that A, B, C, or D on the multiple choice questions.
So we answer the, one dot A or whatever, type, everything typed and then print it out?
Yes, yes. Yeah, I don't wanna fight handwriting.
Okay.
Alright, so y'all work on your, scaling exercise. If anybody needs to borrow,
We're good?
Oh,
Till